Okay, guys, we're going to get started here. First of all, thank you for joining today. We're excited to have you on this webinar and introduce these topics around MCPs and energy and commodity data and kind of what that looks like in our world. Just first, quickly to introduce who we are at NorthGravity. So NorthGravity is a software company that was established in 2018. Our focus primarily is on the energy and commodity space. That's where a majority of our clients reside today. We kind of have offices around the world. We're a team of about 60 plus people today. So again, we thank you for your time, and we look forward to kind of your feedback and questions throughout the meeting today or the webinar. With that, I'm going to hand it over to Ani Sundram, who's going to present these topics around MCPs and kind of the excitement around the energy and commodity space. So with that, Ani, it's over to you.
Awesome. Thank you very much, Travis. So as was just stated, my name is Ani Sundram, and I have been working in client success within NorthGravity for the last 3 years. So you wear a lot of hats, but in this job, but my main job has been sort of deploying AI-driven and data management solutions for a variety of players within the commodity and energy space, whether it be normalizing refinery data across disparate sources, whether it be the parsing and backtesting of historical brokerage data, or validating compliance documents for a renewables exchange. I've been working heavily on how you can utilize AI and other technology tools to help automate workflows and help improve efficiency with how people are able to make decisions off of data within the space. So before anything, I guess I wanted to kind of walk through what our agenda is for today. So we'll start by kind of presenting the building blocks behind some of these main concepts, namely with agentic AI and MCPs. We'll talk about how MCPs can be applied in the broader data world and what kind of applications they kind of have within the commodity and energy data space. We'll also discuss example use cases and something pretty cool we built and are currently in the progress of building regarding an example of how to use an MCP server. And then we'll wrap things up with key risks, governance considerations, and sort of what we want to take away from this presentation. So before anything, we wanted to kind of talk about NorthGravity's own roadmap with respect to our usage of AI. Obviously, the last 2 years have been incredibly transformative for our enterprise, as it has been for almost any other enterprise. To start things off, as some of the foundational models started coming into play around 2024, end of 2024, we started using AI as sort of our way of speeding up our own analyst and engineering workflows, whether it be quickly having a Python script go live to transform some data, or quickly being able to kind of do things to help improve our own personal productivity. Slowly, across the last year, this is now transferred to client workflow automation. So some examples of stuff that we've done within the NorthGravity platform for clients includes the parsing and digitization of bill of lading and invoice documents for an oil and gas marketer, or creation of augmented AI summaries off of output reports regarding refinery optimization. We have gotten to the point where we're trying our best to kind of automate workflows and utilize AI to augment these workflows to really help provide value for our clients. In this process, as again, changes come exponentially within the space, we came to the question of how can we utilize AI to help connect disparate systems? So as I'm sure everyone on this call ends up knowing, there are a lot of different, whether it be data feeds, whether it be systems through CTRMs and ETRMs, which are sort of relevant within the space of how a trader makes a decision or how a oil and gas team makes a decision. So really the core question was, what if these agents and usage of LLMs that we build could talk directly to these many disparate systems which commodity teams rely on? That is sort of what led us to where we're going now with our presentation with respect to MCPs and agentic AI. So with this in mind, let's just sort of set the stage on some of the key conceptual building blocks before we get into the nitty-gritty with MCPs. So obviously the first term I'm sure everyone on this call has heard about, and that is an LLM, aka a large language model. So think of this as sort of the brain in this case. So a large language model has the ability to understand natural language and generate responses and outputs using natural language, whether it be summaries, reasoning, explanation. However, an LLM itself cannot touch your systems. It needs sort of tools and reliable data to kind of make itself useful. Off of that is the concept of an AI agent. So think of an AI agent as an instance of an LLM, which can actually take actions using tools. Maybe you train it on a certain system's SDK to help it understand how you can retrieve data. Maybe this agent can go ahead and automatically run workflows at a scheduled time. This, with the building of the tools, building of the permissions, guardrails, and governed access, is sort of the next step of how you'd be able to help automate enterprises' workflows. Now, this leads directly to the concept of MCP, otherwise known as Model Context Protocol. So at a high level, Model Context Protocol is sort of an open standard or open language, which Anthropic has created to allow AI agents to connect to tools, systems, and data in a safe and standardized way. Think of this as sort of like the USB-C for AI. One universal way to be able to have your agents, plug them into to relevant tools to take actions on external systems, and have that be interchangeable, irrespective of what model you're using. So again, the big point here is allowing us to connect to those external systems, but giving you the flexibility to be able to use those connections across different foundational models. So let's just talk about how this fits together within an example workflow, aka an analyst trying to access an external data management system, more specifically the NorthGravity platform. You, the analyst, would go ahead, ask the LLM a question in plain language. Hey, how does this data look like? Please query this last week of history, et cetera, et cetera. Your LLM paired with an MCP server, which kind of provides you the menu of approved tools to be able to execute within a given system, exposes those approved tools and talks to the outside systems, whether it be uploading data, whether it be querying a certain database, whether it be converting data into a desired output format. At this point, after you kind of call these tools, the MCP server would go ahead, take those actions, obviously under the assumptions of governance and any sort of entitlements within your external system. The main point here is that you're able to ask the LLM something in plain language, and with the assistance of a agent connected with an MCP server, it is able to act on actions within these external systems just using natural language, making sure that you don't necessarily have to be an expert with whatever system or API or whatever that you end up calling using the server. So again, this is just sort of examples of this in action, right? So one example is, hey, we have vendor files which arrive to a certain repository today. Which one of these are missing? Or convert this broker file into time series and load it. In these sort of examples, the agent perhaps has tools which are linked to the API or SDK for any given system. The agent can go ahead, inspect the structure of the data that you're dealing with, maybe detect, hey, this date column is in this format, just so it can normalize it. And it can go ahead, reshape this based on the data schemas present within this external system, and then upload it. Again, just another example with the third one, compare the last two curve files and explain what's changed. The agent could go ahead, theoretically, compare the versions of data, highlight any relevant outliers, and use natural language to summarize the change while doing this with the context of those two last curve files. So again, the same sort of, as you can see, we have a lot of different capabilities here, which provide some level of a force multiplier and productivity enhancer in how someone is able to interact with these external systems. So now the question comes, we've talked about sort of a broad perspective here. What makes commodity and energy data hard and difficult to be able to do such normalization and aggregation? The short answer is there's a lot of data in a lot of different places, whether it be APIs relevant to an exchange, fundamental data off of government websites like EIA, or vendor feeds. This data all comes with their own APIs, own schemas, own symbology, and even own metadata with respect to units and currency. Additionally, these files end up being in a lot of different places, whether it be in an FTP or even whether it be in an enterprise-specific SharePoint instance. So given this, there's definitely some level of tediousness with respect to the ability to be able to QA data and the ability to be able to automate workflows. And when you're dealing with time-sensitive decisions, it is very important to sort of be able to go through things and address the whole idea of data quality risk or the risk of not calling everything that you might need when analyzing something. All in all, it's very clear to us that for the general energy trader or general analyst workflow, this process of aggregation and normalization eats time before any analysis or any decisions or insights are made. So that is the kind of key problem that we ended up noticing in that space. So where could MCPs come into play within commodity decision support? Really what it comes down to is this allows us to go from fragmented data across disparate sources to faster explainable decisions. Assuming we have the proper tools, it'll allow you to quickly upload or download a file from a given repository, detect outliers, convert files between formats to allow you to save and query data per the choosing of an external system. This, again, kind of allows us to speed up analyst decisions and lowers the operational risk on this end. Just to go through some examples on the right, let's just say you have a renewables exchange. It could be very plausible that the renewables exchange gives traders who might need to validate compliance documents regarding their credits, et cetera, I can see a situation where an exchange will give these traders a chatbot, which is connected to an MCP server, to help you say, hey, here are my compliance documents. Please validate these. Please let me know what might be wrong in terms of submitting these and being able to trade the assets which I own. What is very cool here, again, is even in this sort of compliance use case, there's a lot of robust mechanisms for logging and for auditing whenever an action is created with an MCP server. Let's just go through another example, specifically to the oil and gas space. As we were discussing earlier, fundamental data and refinery data kind of comes in a variety of different shapes and from a variety of different sources. Perhaps a trading desk has the ability to ask an agent connected to an MCP server to onboard new fundamental refinery data, validate it, normalize it into some sort of standardized format, and flag anomalies before they make a trading decision. Again, with this, we're able to, once again, aggregate, combine data from a bunch of disparate sources without necessarily having to rip out existing systems or build one custom connection for every single system. That is the power of using MCPs. So with this in mind, we went ahead and actually started the testing and building of an MCP server connected to the NorthGravity platform. Obviously, we're not at a final stage with this where this is completely in production. We have just started this operation. But what we have gotten to is a tool which allows you to upload and download files, allows you to detect outliers within new files, allows you to save data within a time series friendly schema, allowing you to query it on the back end, and even allows you to use NorthGravity's pipeline module to actually automate end-to-end workflows. So with this in mind, I'm actually going to switch over. So we will switch over to Codex, where I will actually walk through an example. So as I just discussed before, we built a localized version of an MCP server just to prove out some of these examples. So let's just start with a very quick one. Let's just say that I'm interested in saving data within a given repository, aka a data lake group within our platform, in a specific way. All I'd really need to do is go in. So we have this document that I've downloaded right before this call regarding EIA weekly petroleum data. So all I'd have to do is click send. And this will take some time to sort of get the correct tools and menu of functionality ready to actually make this happen. While this continues, I just kind of wanted to briefly discuss the sort of work that kind of went behind this. So at a long story short, what we really did was we connected the server to learnings that the LLMs were able to have from the NorthGravity SDK, allowing for secure login and secure communication. And we created individual tools which link to our platform components to allow it to conduct actions. As you can see here, I just set up some permissions to say, hey, go ahead and run this tool. So I will click allow. Let that take a couple more seconds. And there we go. So the file is now loaded into that group as a source run file, as a source file. Just to kind of confirm to you guys how this looks, as you can see right here, within sort of our test environment within NorthGravity, that file has been saved here. I can go through another example here on this end as well. So along with uploading files, we have the ability to actually go ahead and also save data within time series. So again, here in this case, I'm just taking a file in an unprocessed format, saying, hey, this is the date column, this is the symbology, and I'm able to pretty effortlessly actually save this as time series queryable data within that same group. So give us one moment for this to run. So again, just to kind of explain what's going on here, it has, again, gone ahead and found the tool that we have built behind this MCP server to allow it to take this action. And you can see right here, if we go back, that file has been saved in a time series format and has been structured for seamless queryability. So let me go back to our presentation. So again, these are some of the examples of some of the already existing instances and tools that we've built for this MCP server. But where does this go next? So as we continue building this out, we want to get to a point where this ends up being a full-fledged platform assistant. Instead of having people have to be necessarily knowledgeable of our platform or even any external systems connecting to the platform, we are building something to allow you to go ahead and create sort of an end-to-end workflow for an ETL process, allowing you to QA and query, hey, what files are missing today? Or are there any outliers within this respective file? So our goal is to sort of allow these items to give you a governed with our relevant entitlements, access controls, and security, but AI-assisted platform experience really, again, acting as a force multiplier as you go ahead and onboard and analyze new data. So with this in mind, we've obviously gone through a lot of sort of positives and a lot of points regarding the value of all of this. Let's talk about some key risks and how we control them. So obviously, I went through situations through that local MCP server where we're writing data and we're accessing certain groups. So obviously, there's always going to be a risk of sort of unauthorized access and unsaved writes. To sort of be able to control this, you have to treat the deployment of an MCP server as almost the exact same thing as any other software deployment, including robust role-based access controls and dataset permissions within that external platform, and also staging your deployments to where maybe when you're testing this, we only start at a read-only level. Maybe we include a human in the loop before any sort of writing into production groups. Segregation of environments between production and development. Lastly, we also believe that having robust logging behind each MCP server, whether one you create or one you end up accessing, really helps understand sort of root cause behind issues behind this and allows you to quickly fix them. In terms of other risks we want to discuss, obviously there's always the counter argument of, hey, AI can end up hallucinating or providing you a confident wrong answer, for a lack of a better term. In these cases, again, nothing kind of is foolproof. You're going to have to go ahead and test and validate and have a staging process for each tool underlying an MCP server before you trust it. So this is, again, where logging comes into play. This is where anchoring and ensuring, hey, any answer you give me, please make sure it's only grounded on data relevant to this external platform. These kind of tools really make this way more minimal risk. And again, it's very crucial to stage your rollout and keep a human in the loop. Now, the last point we wanted to bring out was the sort of idea of cost concerns. So I'm sure everyone has read the recent article regarding an unnamed Fortune 100 company who accidentally spent $500 million in 1 month for their AI budget. Obviously, more tool calls equals more tokens and spend. What is important here is, again, to have strict, but at the same time, making sense controls for how the budgets behind a user and behind the automation of a workflow. So, for instance, perhaps you set up a sort of token limit for each user where any overages require leadership approval. Perhaps that also includes budgets on the per workflow side of things as well. Another recommendation we sort of have is obviously these models are getting better and better. However, not every single workflow automation or task requires the best model, requires you to use Claude Fable. What we recommend is sort of defaulting your enterprise usage of AI to maybe using a simpler, a cheaper model. Perhaps instead of needing to use extended thinking, you have things default to instant, requiring you to opt into more advanced models and also maybe even get approval for high cost runs. So enterprise controls like this really make these risks minimal and allow you to actually use tools like an MCP server with confidence. So again, we just want to kind of briefly go through this. Back to the original point, the deal with being able to have sound governance behind MCP servers is not that different from the sound governance needed with deploying any new technology solution. So really the three main points we have here are that, hey, let's kind of start with the automation of low risk tasks to start. Let's include humans in the loop until there is a high level of confidence behind the outputs and behind what an agent ends up writing. And let's enforce permissions. Let's ensure that a agent is not necessarily permission to things irrelevant to its function. By validating outputs and by setting these controls, we're able to kind of allow these processes to earn trust, which again, that trust is very important in expanding the sort of workflows you can automate, expanding the usage of said servers, and kind of building confidence behind the usage of all of these things on an enterprise level. All in all, if we wanted to kind of walk through, I guess, some key takeaways across. So the first point is, as we've already discussed earlier, through MCP servers, AI really does become a force multiplier for analysts and enterprises. It allows you to access disparate sources through one common interface or one common connector. It allows you to kind of democratize access to where, hey, to pull something from an ETRM, perhaps you don't have to be an expert in that ETRM. You can use your natural language to kind of help work on whatever workflow you're responsible for. And additionally, it does increase the productivity per analyst and does so in a governable and auditable fashion. As I'm sure almost everyone knows here, LLMs are getting better and better. Just a couple days ago, they released Claude Fable, and all of these sort of LLMs have gotten to a point where one guy releases one thing, another guy releases one thing. So the sort of the table stakes at this point has become the idea of the sort of functionality. Like the edge is no longer any one given model. The edge ends up being the connections, and the edge ends up being how you're able to allow your agents to safely talk to external systems, which is why MCPs are a key differentiator and something very valuable to have within the oil and gas space and energy space. So thank you everyone for listening to our short presentation and demo. If you have any more questions or you're interested in some of the use cases I presented or even the NorthGravity platform as a whole, feel free to contact the email you see there below.
Ani, obviously great presentation, and it's great to see these MCPs and kind of the usage, right? Again, we see across the commodity space that the kind of deployment of these is just starting, right? And we see, somewhere in the range of 10 to 15% of kind of both data and tool providers having these available. It's fully our expectation that this will continue across the board. As you stated, it is one of the differentiators to the models, and that's great to hear. Some questions, Ani, that we got in. One question is kind of how does the process of setting up an MCP look like? How do you do that? Do I need to know how to code, or how do I actually get an MCP set up?
Sure, great question. So I'm just going to actually walk through an actual example here. So there's a couple different concepts here. First is the building of an MCP server. So obviously there is some work behind sort of the creation of tools and making sure your tools kind of match up with whatever system you end up wanting to access and conduct actions on. Luckily, for the actual configuration for an end user to set up an MCP server, it is a relatively straightforward process. So as you can see from my screen, after creation of the sort of folder and underlying details behind the server, all I really have to do is some very basic configuration. So go in, set up a server. We might have to set up some variables to ensure that you can properly authenticate and you have the right permissions to access said MCP. But I would pretty confidently say the actual setup of using of an MCP is not something you need technical expertise for. It's more of a configuration issue, which makes it, again, very valuable for allowing newcomers and allowing people kind of a little bit newer with AI to be able to use them.
Yeah, one more question for you, and it's around, do we actually need an MCP to do this? Or is it just a wraparound the API could build ourselves?
That's a great question. So theoretically, each of these tools could be a wrapper. So what I mean by that is theoretically, for every single system or every single action you can do, you can build a bunch of one-offs. You can build a bunch of one-off connections to say, hey, access this here, access this there. What is really the differentiator with MCP servers is this is sort of a one-stop, again, back to the analogy of USB-C for AI, one-stop place to be able to, one, create these tools, but then after you create these tools, I don't necessarily just need to use Codex or ChatGPT for this. It becomes interchangeable. That connection becomes interchangeable due to the model context protocol across most of the major LLM providers, Gemini, Claude, etc. So really, again, along with the ability to access external tools, which again can be done, as the question says, multiple different ways, this again provides the ability to kind of have interconnectivity as each of these models gets better and better. You'll have the ability to utilize it across a bunch of different models. And more importantly, MCP, the Model Context Protocol, provides a lot of considerations regarding governance and auditability, which is probably something worthwhile for a large enterprise as they use tools like this.
Well, again, I would like to thank everyone for joining the call and thank Ani for presenting. As Ani mentioned, if there's any interest in discussing these topics further, please feel free to reach out to us. We would love to chat. But again, we thank you guys for your time today, and hopefully you've gotten some from this presentation. Have a great rest of your week. Thank you, guys.
Thank you, everyone.